But onto today's subject, which is design briefs. And here at Andon, we are well versed in designing complex temporary work solutions. Some of us, including myself, have experience both acting as a temporary works coordinator as well as teaching courses for temporary works coordinators and temporary works supervisors. All designs require some form of design brief, whether that's formal on a template sheet or informal, getting the right information on in an email. But we've seen great ones, and we've also seen very, very bad ones. Great design briefs lead to better designs every single time. Today, we're going to share some of our experience in that. So today's topic, temporary works design briefs. Temporary works can be fraught with risk if not planned properly. Here are some standout examples of large-scale temporary works failures in the last 20 years or so. So we've got the Florida bridge collapse in America, the report from OSHA, who are the American equivalent to HSE, as I understand it. That's a really great report and makes for some quite worrying reading. There's design errors, also lack of action on site, and then bridge collapse. So yeah, that's worth tracking down. We've got Gerrard's Cross in 2005. So that's a precast segmental arch which collapsed during construction. Nichols Highway in 2004, large-scale excavation collapse, and Didcot Power Station in 2016, also a large-scale collapse from pre-weakening works. We have got a webinar that covers the temporary works flowchart review, and that covers the procedural control of temporary works more generally, as opposed to these design briefs, which we're focusing in on. So you can see that one on our YouTube channel for a bit more information. But how long has this been happening? Well, quite a while, and the required control is becoming more and more important as structures that we build become more complex. So if we go right back to 1909 in Newport Dock, here we've got a photo of what's left after the collapse of a large excavation support system. It's a large earthworks failure, 38 were killed, but we don't actually know if this figure is accurate, as they didn't have the same registers as we do today and who was on site at the time. You can see some chaps in bowler hats on there instead of the modern PPE that we have here today. This is the earliest temporary works failure that's referenced and recognised as such. If we move along a little bit, we've got Loddon Viaduct, which is a bridge just outside of Reading, and it's the construction of one highway bridge in each direction. During the construction of one of the bridges, the false work failed into the river below, leading to a massive collapse during the pour. And 3 were killed during this incident, which was more by luck because it happened on a lunch break and they had staggered the breaks so that there was a reduced number of people on site at one time. And also there are references from those on site at the time who said that as they felt a slump in the deck as the thing started to go, some of the operatives who were close to the bridge that had just been constructed were able to jump across the gap from one side to the other, which is quite astounding, really. But so during the 50s, 60s, and 70s, there were a number of large-scale collapses that were the results of poorly planned temporary works. And this led to the industry leaders sitting up and thinking that we need to do something to tackle this issue. And it led to the Bragg Report, which reviewed the failings in the construction industry as it was and identified a number of recommendations, most of which were incorporated into the British Standard for Temporary Works, BS 5975, which we still use today. It's still current. It's not been superseded by Euro norms. And some of those recommendations from the Bragg Report, which you can see was in 1975, are listed here. So horizontal loads, that's taking into account lateral stability. Again, reviewing lateral stability is lateral lacing and bracing to provide that lateral stability. The use of proprietary equipment and their instructions of use. We've got the 3% horizontal load rule, which is to make sure that the temporary works that we construct is at least stable under some kind of horizontal load. Discontinuity of false work beams and jack extensions and the proper use of those. Instructions for the proprietary equipment to make sure that there's good manufacturer's guidance on how it should be used. engineering courses, such as courses at university or produced by CITB, whoever, that they reference temporary works. The management of temporary works as well, which is carried out through the procedural control, which is essentially laid down in BS 5975. And the introduction of one individual in the construction organisation that has the duty of ensuring that all of the relevant procedures and checks are carried out, and such an individual being known as the temporary works coordinator. That phrase was coined in the Bragg Report. And then the last one that I've put on there is the importance of design briefs. And this is especially prevalent now that the temporary works design is commonly carried out by engineers that aren't based on site, and therefore the brief should identify interfaces that aren't clear to somebody who's not familiar with the site, who may well be designing temporary works. And it's worth noting that at the time of this publication of the Bragg Report, that the construction industry was very different to what it is now. The health and safety legislation was just beginning to bring improvements onto site, and there was little subcontracting of construction work, with most trades being carried out by the main contractors' operatives. So now most construction work is subcontracted away, or with the principal contractor, and that's why the CDM regulations play a key role in ensuring that the duty holders are competent, and those appointed to plan, manage and monitor their work, which in this case is to plan, manage and monitor temporary works. And the Bragg Report's legacy from 75 is still sending ripples through the industry, and still relevant even now, the turn to from British standards to Eurocode design. But we can essentially boil it down, the importance of design briefs, to these kind of conclusions. So we know that the temporary works can potentially be dangerous if not planned or managed properly. And we also know that a large part of planning and managing temporary works is getting to the right solution. Getting the right solution goes hand in hand with design. So therefore, getting the design right is absolutely key. Thus, getting the design brief correct that informs the design and arrive at the best design solution is therefore critical to the prevention of those potentially dangerous situations arriving on site. And the design brief is a keystone to that design process, and getting it right is very important. The design brief comes before the design. Shock horror. The design brief comes before the design, and can be prepared well in advance, really, when you know what the construction strategy is going to be. And it's written by the temporary works coordinator usually. However, they can delegate it to somebody else, but it's the temporary works coordinator's duty to make sure that there is one, and it's to a good standard. Once the construction or demolition strategy has been agreed, then that's when you know what kind of temporary works solutions that are going to be required, and you can start putting your briefs together. So we have an online temporary works flowchart which takes you through the whole process of the temporary works from project inception to completion. There's a link here which I'm sure Chris can grab and put down in the chat. It's also available from our website, or if you just type in temporary works flowchart. So I'm just going to, once you click that, it'll take you to a page where you can log in, and it's free, and then you choose the most appropriate option, whether it's principal, contractor, manager, contractor, or a subby.
That's in the chat now for you, Josh.
Thank you very much, Chris. Thank you. So then you'll come to an interactive flowchart, which with all the references to 5975 tethered to the design process. So you can see here where the design briefs can be written is once the temporary works register has been filled in, or at least started. The temporary works register is a live document updated as the project grows. So the design briefs can therefore be written once that process is going forward. The design briefs come here before the design team are selected, which it can be, and they can also be issued to prospective temporary works engineers when you want to get quotes back, and then therefore be ready and waiting in draft form until all the information is available to enable a design to start. So that's where it sits. That's the history behind it. And I'm going to now hand you over to Dave, who, now we know the history and where it came from, where it sits, who's going to take you through the content of a design brief itself. So over to you, Dave.
Yeah, so we'll start with what 5975 says a design brief should be. So the important things here are that it will provide the intent of what you're looking for and the information to let us as a designer carry out that design work. 5975 also notes that we should be given enough time to carry that out. So telling us a crane's coming next week isn't ideal for most situations. It doesn't need to be a formal document, but a formal document gives you a bit of guidance on what to think about and what to issue to us as designers to allow the design to be undertaken. So even for a small job, it's probably worth having a think about it, having a sit down, a look at all the kind of pointers that we're going to go through now, and then kind of get the information together to send out. So Josh, we want to move on. What should be included? So we've sketched out a little bit here on what kind of we feel as a designer should be included. There's lots of design brief templates. Most organizations have them, but we've just kind of gone through what we as designers feel is the most important points. So there's all the usual things there. Before we get on to the design check and the implementation, the task number, a lot of organizations have a BIM execution plan for their projects or templates that they would like designers to use. It's always helpful if we know that at the start, rather than we've issued design drawings and suddenly we need a new, on our template, we've got to redo everything that way. The due date is also very important. We need to know when you're planning to get this constructed on site. And often we get told yesterday, but a realistic due date is very important. So along with that, the category of check, if Josh clicks now, we've got your design categories of checks as outlined in 5975. Cat 0 is essentially, it's a proprietary bit of gear. It's checked by the designer carrying it out, or checked by someone else in the design team. The Cat 1 is it needs to be carried out by another member of the design team. They get to review the calculations undertaken and the design produced. The Cat 2 is in the same organization, but a separate set of calculations should be carried out to prove the design works. The checker doesn't have access to the designer's calculations. They do it completely independently and should be completely independent of the designer. And Cat 3 is exactly the same, but a separate organization or a separate legal entity carries out the design. The implementation risk is quite often confused with this, but slightly different. So the implementation risk is more to do with how is the design or the temporary works going to be installed, combined with the consequence of if it fails. A hoarding in a field is quite different to a hoarding on a railway station platform or in a busy kind of shopping centre. The consequence of that failing is quite different. And that's what the implementation risk kind of outlines, is who is installing it, how complicated is it to install, and what is the consequence if it fails. So going on, the description of the temporary works required. So it's important here to think about what the problem is rather than what you think the solution is. We as designers are quite good at coming up with solutions, but if you can outline the problem, it may provide you with a better temporary work solution. If you've got a reinforced concrete retaining wall you need to construct, you can specify sheet piling and we'll design sheet piling. But if we know what the constraints are, we may be able to come up with a better solution to that. Can we use batters? Can we use the reinforced earth wall and sequence the job better? There's a lot of options. So it's important to kind of look not just at what you think the temporary works are, but also what is the problem that needs to be solved. It's also good to know the location. If we've got kind of wind loads or kind of any other loads on the project, we need to know where it is to carry out those calculations. Also, is there a site visit required? Do we need to look at what's there as a designer? Do we need further information? So that's that. And then we'll look at, do you have a preferred system? So this is where you can go with what you are looking for. Do you want proprietary gear? Do you want fabricated steel work? It's useful to know what you are looking for there, and then we can take that into account in the design and aim to provide you with what you're looking for. So like post in hole hoardings, campage-based hoardings, kind of give us an idea of what's coming. Next one is the ground investigation. So this is quite often where we get the poorest information. What we're looking for is some kind of parameters that we can, or something that we can derive geotechnical parameters from. So pictures of a trial hole isn't great, but a full SI report is really good. Somewhere in between is carrying out SPT tests to give us some geotechnical parameters in trial holes, or plate bearing tests of a subgrade or formation level are also really good. So that's what we're looking for. Also, with a lot of things, adjacent slopes or excavations are very important to ground properties when we are designing crane positions or foundations for things, because it massively affects the ground bearing capacity. Next one would be the design limitations. So this is more what is around the site. We've both got contractual limitations. What kind of contractual issues around? Are there external approvals required? Is there a party wall award? Is there a network rail asset? Think about what will affect the design. Do we need to carry out Form Cs or AIPs to allow the works to be undertaken, because they can cause, they add to the timeline prior to your temporary works being installed. And then I can't remember which one is next. So Josh, we've got the loading conditions. So what we're looking for here is, it's quite often with tower cranes, this is more of an issue, but you'll get a temporary tower crane base with permanent loads onto it. And that really affects what the design is going to be doing. We need to know what those permanent loads are, when they're being installed, and for how long for, to allow us to do this. If we're installing a sheet part wall, do you have a mobile crane behind it coming up in the future? Because that is clearly going to affect the design. It's not just a standard surcharge behind your sheet part wall. And then we're looking at kind of service conditions or imposed, or are there any services in the area? Do you have service drawings you can provide? Have you confirmed what services are in the situation? Josh, you can just move on to them. There we go. And access limitations there. So what we're thinking about is, can the temporary works go in and be removed in the same way? If you've got basement propping that's going in and you're constructing a new structure, how will you remove those temporary works, or how do you envisage them being removed? If you give us an idea of what your construction sequence is, and when the permanent works provide that permanent support, we can then look at how to design the temporary works so they can be removed easily and without causing too much havoc. And then I think that next one is, the existing underground or overground services that may affect the temporary works. Are there overhead power lines, or are there kind of chambers or attenuation tanks where you're looking to put cranes? Because that will affect what you can actually carry out on site. I think that is the end. So to summarize, we need to know what things need to be considered. We're kind of thinking, we don't want just a link to V4P with all of your design drawings. That's not entirely useful, and it's going to waste a huge amount of our time going through them to get the drawings. We need what is relevant to the temporary works at hand. Permanent works or historical drawings are very useful when looking at new or old structures to allow us to kind of carry out our work. As we've gone through, any kind of external approvals required from rail, local authorities, significant risks that are due to the design of the permanent works or kind of the area around the site, and environmental risks as well come hand in hand there. An outline program of what you intended to construct and when, and the access requirements. If you have preferred equipment, would you like to move or reuse your temporary works? Location is essential for a kind of wind load assessments. And then, geotechnical reports and the timing of the removal. So they're kind of the headline things to consider when producing your design brief. And what does that allow us to do? So allows us to solve the problem you've got, design something that is appropriate for the reason you're looking for temporary works, essentially. We can use accurate information to make the designs better and safer. We can avoid revisions and get the whole process completed more quickly to the timelines that are required, because they are often urgent. Ensure the correct approvals are in place, and avoid rework if things have been installed or designed and installed without the removal of the temporary works considered, or the new permanent works considered. It avoids rework on site, more cost, more people at risk. If we get garbage in the design brief, we quite often do not produce the best designs. We need that good information at the start to provide the designs that you are going to be wanting, or the best design for your potential problem. So now I'm just going to go through, it's a fairly fictional project, but what we would consider to be good information for a simple kind of crane position. So I've gone through here, if Josh can just move on to the next slide. Crane position, who's designing it, dates required, a brief description of what they're looking for the crane to do. It's there to remove an advertising tower, it's to be positioned here. We'd like the outrigger position designed, and for you to check the services underneath the outrigger position to ensure that no damage is going to be done. So it's a fairly kind of simple design brief. It's a crane position. But what is interesting is that for a crane position, you need quite detailed ground information. So gone with their preferred solution. If they need extra load spreading, prefer timber ecumats. They've attached some SI, stated which borehole is closest, and then provided construction drawings on what the service yard at the rear was made up of, as well as some notes regarding previous work they've done that showed that the geogrid wasn't installed. So it's kind of a makeup of concrete slab on type 1 with no geogrid. That's really useful to us to allow us to do the design. Stated it's not near any network rail assets. It's going to be done as a contract lift, and the imposed loads from the crane, which is being supplied by the crane supplier, along with the standard mats that the crane supplier will be bringing with them. So that gives us a good starting point for our outrigger design. They've then also attached some service drawings for the crane location, along with some pictures where they had in previous works confirmed that services were both there and at the depth shown on the service drawing. That's really good. That's what we're looking for. And then they've attached all the information that they've kind of gone through in the design brief. So that's what we are looking for. It doesn't have to be a huge amount of work to produce a design brief. You just need to think about what information is required for the design. And it may be useful to talk to the designer before, or your proposed designer prior to starting this, so that they can inform you of what they would be looking for. We're happy to take phone calls on designs and just kind of think about what we need before we start, just so that we can give you the information and therefore you can give us the information. So I think we then move on to Josh's example.
Okay, thank you very much, Dave. So I've got my little case study, which I'm going to talk about on the process of a design brief creation. So this project is Old Granada Studios in Manchester. The principal contractor was Bowman Kirkland, and we were the temporary works engineers for the project. So I'm going to focus down on a little part of this project and talk to you about what the problem was. So you can see from this 3D interpretation on the left-hand side that the basement works were already completed. They were very tricky, and then we were out of the ground, and we were looking to construct the ground floor slab and then start bringing up the superstructure, which was a steelwork frame and composite floors. On the right-hand side, you can see there that that's part of the process of the ground floor slab being constructed. There's some remnants there of the basement propping works, and there was a building next door which was being retained. So the task was to erect the steelwork frame whilst operating on the ground floor slab, which was a raised element of the structure. The tower crane was being used to handle the steelwork into place, and then a couple of mutes were required to enable the fixing of that steelwork. So the problem was that we need to get plant onto that ground floor slab to operate, which was a temporary works item. So let's go through the design brief example here. So we've got the project name and task name. This particular project had a BIM execution plan, so we had a specific task number that we needed to reference in drawings. The design category check, I've ticked a couple there because depending on the size of the machine or what's being used, it might well be Cat 2 or Cat 1. It depends really on, we carried out a Cat 2 check on this one, but it depends on what's around. Like Dave talked about the implementation risk. So if there's a particular structure that's a sensitive asset near there, then the consequence of failure is high. So then therefore you'd want to go for something more like a Cat 2 or Cat 3. So that's open to interpretation really. And if you would require a bit of guidance on what that should be, then as Dave said, touch base with your designer just to scope out. Because a 2-ton lit machine operating on there would be Cat 1, but then when you start getting to larger machines with larger failure zones, then you want to be upping that independence on the check. Similarly with the implementation risk, is really depends on the project and the location of it, as well as who is carrying out the works and what the works are. The due dates there, I've put a couple in, well, a few in there in terms of when we'd like a concept time to discuss what the design is going to look like, when we require a working design for construction drawings, and then a start on site time. Now, you're welcome to be a little bit cheeky on that just so you can get your best out of your design engineers. But as we've been saying, put a realistic date in there. Don't put ASAP, because ASAP means a lot of different things to different people. If you put a date in there and it's the next day, then you're going to get a phone call from the designer thinking, blimey, mate, I'm not sure if I'm going to be able to do that. Can we agree something more, and that starts the conversation rather than somebody receiving ASAP. Yeah, I could do that as soon as possible for next Friday. So yeah, we'll just go with that. And then they just sit on it. Okay. So it opens up that conversation. The design brief originator, that's just kind of information, originator and the temporary works coordinator, and then some dates on there on what you'd like. So the description of the temporary works required was the 15-ton mute required to operate on the ground floor slab to facilitate the installation of the steel from levels 1 to 6, and the structural details attached. And the ground floor had not been constructed yet at the time when the brief was submitted. The mute will need to operate over the whole slab over the course of several weeks during the steel erection works. The preferred methods, well, the structural engineers for the project have stated that the proposed mute point load from the wheel is too great, therefore simple back propping to the ground bearing basement slab beneath with acro props or similar, because we've got easy access to acro props on site. So that's kind of preferred. If we can, we use acro props. The basement slab is essentially the ground conditions underneath any back propping, and then the pile design and site investigation report are attached. The design limitations, well, the mute needs to access all areas. So we can't just have your design coming back saying, yeah, you can use your mute here, but you can't use it there. It needs to get everywhere. Particular loading conditions, the mute has an operational weight of 15 tons, see spec sheet attached. The mutes will be operating on a live construction floor, therefore design must consider construction loadings on the same slab as mute if possible. So they may well be storing pallets of materials or beams on there, so that's something that needs to be thought about during the design. It's not going to be an isolated operation. Access limitations. The ground floor slab has no access limitations. There's no difference in floor height between them. There's no ramp required to get onto the ground floor slab. The basement is accessed via hoist and a new stair core that's being constructed. There are no services in the area as the structure's just been constructed. And the other information, we've got an attached sketch from the steel erector of the proposed mute positions, and I've referenced what that sketch would be. So it's just a little kind of drawing, and there's no third-party approvals necessary. And then any additional information is kind of, well, this is the method statement, this is the ground floor slab details, etc. When there's a structure with lots of different drawings, then I think it requires the kind of designer touching base just to let them know what you require, because that can be quite extensive. So that's my interpretation of what the design brief could be. Okay. But on this particular project, we worked very closely with the principal contractor, Beaumont and Kirkland, and we were able to plan very early on. And the assessment of the temporary loadings on the structure resulting from the plant, such as the MUP and the cherry pickers, and that proved quite interesting. A key item is that the slab hadn't been designed for those point loads, and it also hadn't been built yet. They hadn't constructed the slab yet. So is there a better solution to backpropping? Well, yes, possibly. So what we looked at, because the slab hadn't been constructed, so in this real life situation, we reviewed the loadings from the various plant and checked that the new slab designed for bending, shear and deflection. And we checked punching shear on the column heads and the column capacity, as well the loadings into the pile. So we did a full ULS analysis on the structure and SLS analysis too. And we concluded that we could get rid of the backpropping if we added additional H12 bars at 300mm centers and installed them in particular areas in the bottom face where the slab was failing. And so it required local strengthening to that slab. And following this conclusion, we proposed and produced this drawing, and the proposal, which was to essentially remove the requirement of backpropping and the associated costs of installation, hire, and then again removal of it. But in addition to this, the basement slab finishing works could proceed because there's no propping in the way, which was a fantastic result, because then this solution meant that there's a very effective in speeding up the program, reducing overall costs whilst also maintaining the required margin of safety. But to enable that, it did require some forward planning. So it's a case of thinking ahead and getting ahead of the game. So hopefully these case studies have reinforced what can be achieved with writing a good design brief. Planning early pays dividends. So in summary, what makes a good design brief? Providing succinct, accurate information in good time, highlighting risks to increase safety through design, materials available and preferred materials. It's just to better inform the designer of what tools are available in the toolkit that are easily available and effective to get onto site. An idea of what is expected without leading the designer. So this one is key, really. The designers that you employ are experienced problem solvers, hopefully. Hopefully you're getting the right designers, and they are well experienced in the field of temporary works and temporary work solutions. So therefore draw upon their expertise on how they can solve the root problem and not design the solution that you've necessarily proposed. It may well be that the solution you think is best is the correct solution, but in my experience, it's best to provide the overall problem in the brief with an idea of what the site team would like to do. And it may be then that there's a concept stage is necessary to workshop some ideas of whether, like Dave's example of the whether a batter is better or an exclusion zone, or whether you can sequence it and use the permanent works so that you can remove temporary works. And then that kind of draws out the design stage a little bit, but it'll by planning ahead, it's going to be much more effective in the long term. So designing for more complex solutions, it is usually a progressive affair with disciplines in the project team involved, but with the designer taking the lead role. That's where we, in our experience, we find that the best solutions are found and determined. Timescale, making it realistic and not putting ASAP in there, as it means lots of different things to different people. Put a date and then start that conversation rolling. Design life. You'd be surprised in what an engineer can do with the knowledge that something's going to be used once as opposed to being used repeatedly over the course of 6 months. So knowing the design life leads to a more lean and efficient design. So ultimately, a design brief is so that we can understand the problem and therefore get to the most efficient, the safest, and the most cost-effective solution quicker to therefore facilitate works better on site. Essentially, that's what it's all about. And that concludes our webinar today. It brings us to the end of our presentation, but hold your horses, because that's not it for the subject. There's a whole load of information out there on temporary works design briefs, and all sorts of bits and bobs. So I've just listed some bits here. Some documents worth getting familiar with. So there's the temporary works guidance on constructability of temporary works, as well as loads of content on their website, which is loads of content which is free. That's a really great resource there. We've got BS 5975, which is the go-to code for temporary works design and the procedural control of temporary works. It's not been superseded. It is still current, and it's something that we reference daily. There's the Safe by Design guidance note on the early focus on constructability and temporary works, which is a really great source. And there's also our webinars and the temporary works flowchart too. So we've got 60+ videos on there now, and they cover all sorts of bits, ranging from demolition case studies to net zero challenges in the contemporary era, to a crash course in plate bearing testing on working platforms. So there's lots of bits out there.